Here we've got our setup for our refraction experiment. If we were at school, what we'd be using is something called a ray box. A ray box is a black box with a light source in it that has a cover with a small slit in. Because we're at home, I don't have access to a ray box, so I'm using a makeshift one instead. I've got a toilet roll tube with a torch inside of it, and I'm using an old card that I've cut a slit into. That means that when I shine my torch through the toilet roll tube, you can see our light ray passing out this side. What we'll have to do if we were at school is we would be given a glass block or a perspex block that we would then place in our light ray, and we would be able to measure our incident and refracted angles to show you that we have a change in direction of light as it passes from one medium to another. Again, because I'm at home, I don't have a solid glass block or a solid perspex block. What I've got instead is a glass bottle that's quite thick, but it's got some liquid inside. So that's what I'm going to be using. It should yield the same results. So if I place my glass block onto my light source, and I'm going to draw around the glass block just like we would have asked you to do at school. So I'll draw that side, and I'm going to draw that side. And I'm not going to do all around it because it's actually unnecessary. I'm also going to draw or indicate on my drawing the light that is incident on the glass bottle, which you can see down here. So I'm going to draw my ray being shone into the bottle, and I'm just going to draw down that side again because I can see it hasn't actually marked on very clearly. There we go. And I'm also going to draw my transmitted ray. Now that's actually a little bit more difficult for you guys at home to see because it's actually quite bright in this room that I'm filming in. I've got a window to my left hand side, so you'll just have to trust me, and you'll hopefully be able to see a little bit that my transmitted ray is kind of round about there. Now I do also have a little bit of a ray being shone this way, but because that's on the same side as my incident block, that's actually not what we're looking for in our experiment. That's just another reflected ray, but we do that more later. So I'm going to take away that glass block, and what you'll hopefully be able to see is that now that I've taken away that glass block, the path that the light should have followed if there was nothing there passes straight down here. So you can see immediately that without that glass block there, we do have some kind of change in direction. That has meant that our glass block has provided us with a refraction. Okay, just going to get rid of the ray box so that we can actually start measuring these angles, because that's the important stuff. This is what you're going to have to do in your GCSEs. This is the way that these questions are going to be laid out. So, just so we can remind ourselves, that's our glass block. This is our incident ray. And this is our transmitted ray. Okay, and that's the important stuff there. Now, just like in our reflection practical, we want to draw a normal line because that's where we need to measure all of our angles from. Remember, the normal line is a line that is drawn at 90 degrees to the boundary of the glass block or whatever medium that you are so happen to be measuring. So take my ruler and I draw on a normal line. That's there. And that's what I'm going to use to measure my incident and refracted ray from. Now, what I'm going to have to do next is I'm going to also have to join up the incident ray and the transmitted ray so I can see what path my light followed inside the block. So I just take my ruler again and I join those two lines together. Okay, so that's the pathway that our light followed through our glass block. And now we can use our protractor to measure our incident angle and our refracted angle. Now, we want to make sure that we're always measuring from the normal line to our ray. So our incident angle is going to be this angle. This is our normal, remember? So it's the angle from our normal to our incident ray, and that is our incident. And then we also have our normal line on this side and our transmitted ray here. That's going to be our refracted angle. Then I'm going to take my protractor and I'm going to measure those angles. So, angle of incidence is roughly about 40 degrees, and our angle of refraction is 30 degrees. So you can see there that once our light ray passes through the glass block, which is more dense, then we end up with an angle of refraction that is smaller than our angle of incidence. So going from a less dense to more dense, the angle of incidence is greater than the angle of refraction. You can see that if we were going to have a look at our transmitted ray, okay, so the one that comes out of the other side of our glass block, and if we draw our normal line here as well, and we're not going to measure these ones, but there's our incident ray and there's our refracted ray. If we go from a more dense medium to a less dense medium, the angle of incidence is smaller than the angle of refraction. So just write that rule down there as well. More dense to a less dense, angle of incidence is smaller than the angle of refraction. And those are the rules that are important for you to follow in this instance. So this is what you'll typically see in your GCSE exams. You might get given a diagram here that doesn't have all of the angles on it, and you'll have to use a protractor to measure, or you might have to tick a box to estimate what angle you have for a refraction given the angle of incidence. And you'll have to be able to recall these two rules. So these are what are important, and this is what you're going to use this week to complete your work.